In this video, we're going to talk about the invert binary tree problem on Leetcode. So we are given the root node of a tree and we need to invert it. So what does it mean to invert a binary tree? We can see it in this example. So whatever is on the left-hand side of the tree originally now moves to the right-hand side. And similarly, whatever was on the right side of the tree originally now moves to the left side. Okay? And this happens on every single level. So if you look at this level right here, 3 was originally on the right hand side of 2, whereas now 3 is on the left hand side. Similarly, 1 was on the left side, and now 1 is on the right side. Okay, and this example demonstrates this as well. 3 was originally on the right side, now it's on the left side, and the same thing for the node 1. So let's try to think how we can solve this problem. First of all, what if the root that was passed to us is none? Okay, what should we return? If the input refers to nothing, right, then we want to just return the root because there is nothing to invert. And now we do the more interesting part. We want to make sure that the positions of the left and the right nodes are interchanged. So in order for me to do that, I will first store the values of the left and the right nodes. So I'll say root.left, it gets stored inside the temp left variable, and root.right gets stored inside the temp right variable. Now I want to swap their positions. So what originally was temp left now becomes the right hand side of root, and similarly what originally was temp right now becomes the left hand side of the root, right? And finally, what this problem wants us to do is to return the root after this swap. I'll just return the root. Okay, so as you might have seen, there is a bug in this code. Okay, running this code by itself will not pass the test cases. So I challenge you guys to think about where we're making a mistake, because this is pretty common when you're trying to use recursion. Alright? Okay, so I'll let you guys pause the video and think about where the bug lies. Okay guys, so the problem is actually in line 13 and 14. Here, as you can see, we only inverted a single level inside the tree. So 7 reached the position of 2 and 2 reached the position of 7, but what about the rest of the children, right? What about this level right here, where containing 1, 3, 6, 9? Those nodes did not swap their values. So in order for me to do that, I'm going to delegate the responsibility to a recursive call. Okay, so I'm going to call invert tree on the temp left node, and I'm going to trust that when this recursive call returns temp left to me, because every call to this function returns a node, which is the root node that was passed, right? So when this recursive call returns the temp left node to me, I will trust that all of its children's values will have been swapped. Okay, and I do the same thing right here. So when the temp right node returns itself to me after this function call, I will trust that all of the children of the right node will have swapped themselves as well. Okay, and finally, after my children sort themselves out, I will just return the root, right? Because that's the goal of this question. You're given a root, you want to return a root after operating on your children, isn't it? So now we're ready to run the code. And as you can see, we passed the test case. So let's see if it passes the rest of the test case. And it does. Okay, so there is one way in Python to improve the code we just wrote. Okay, so here we stored the values of the original left and right nodes, and then we inverted them. But if you want to be more concise, we can do something like this. Okay, we say root.left and root.right now become root.right, root.left. But again, we want to make sure that when the right subtree returns from the recursive call, its children also swap their position, which is why we delegate that responsibility to a recursive call right here. And we do the same thing here, okay, for the left child, like this. So as you can see, the left and the right hand sides are swapped in a concise way, but we did not lose any of the functionality. So we can submit the code again and see if we pass all the test cases. And we do. Okay guys, so that was all for this video, and I will see you guys in the next one.